Hello everybody, and welcome back to another Big Ideas lesson. Today we are talking about the final section of Unit 7, 7.8. So 7.8 is going to introduce just one more factoring method. Let's go through real quick and just remind ourselves about all the factoring methods we've learned so far. In 7.5, we learned about what I'm going to call simple factoring. Simple factoring is the one where, again, you set up a combinator, and whatever you get as your combinator answers, you just put into a binomial. If you get 2 and 3 as your answer to the problem would be x plus 2 and x plus 3. In 6.6, we learned a lot of different methods. We learned 3 of them. In 7.6, we learned factoring, by GCF. GCF, remember, is greatest common factor. This is where, if you can pull something out at the start, you must pull something out at the start of the problem. We also learned 2 more methods from 7.6. We learned that when you can't pull something out, you can use either the AC method or we can use the box method. Both of these involve setting up our special combinator, where we had a value at the top equal to A times C. Finally, in the last lesson, 7.7, very brief video, we learned about the difference of squares, which we can use anytime there is, well, a difference, meaning they're being subtracted, of squares, perfect squares. Today in 7.8, we are going to learn the final method. So there are 6 methods total that we learned. In 7.8, we learn factoring by grouping. And the reason we're learning all these methods is because certain problems require certain tools. For instance, you wouldn't try to hammer in a screw, but you also wouldn't try to screw in a nail. Different problems require different tools, and this is a complete toolbox of factoring methods. Factoring by grouping is no different. It just involves us grouping together our terms in a quadrinomial in order to factor. Now, you might have heard me correctly there. I said quadrinomial, not trinomial, not binomial. Factoring by grouping is used when factoring 4 terms. Let me give you a brief example. Let's say I had the problem here, 3x squared plus, I apologize, y'all. I was looking at the incorrect problem. Let me take another stab at this and find a better one. I apologize, everybody. This problem was actually not a factoring by grouping problem. I completely misread my notes. Let's try this one, which absolutely is, though. 2x cubed plus 10x squared plus 3x plus 15. Notice here we have 4 terms that cannot be combined with each other. We've got 4 different things in our polynomial. We've never learned a method for dealing with 4 things. But the good news is, we kind of don't need to. We already kind of know how to do things with 3 terms. Surely we can just extend it to 4. And you'd be correct if you think this. If you remember all the way back to when we first learned the AC and box method, remember how we had to split our middle term into 2, and then we could group them using the AC method? That's the grouping method in a nutshell. We already know how to do this. The grouping method involves us grouping together pairs of terms such that you can pull something out from the group. So, what would happen if I grouped together these pairs? Let's do a quick check. Is there something I can pull out from each group? Is there a common factor between the terms within each group? Well, in this first one, we can pull something out because both 2x cubed and 10x squared can both be divided by 2. And how many x's could I take out from both terms? Well, this one has 3 to give, but this one only has 2 to give. So let's take out 2 of those x's. 2x squared. Now all we need to do is write down what's left over. When we take 2x squared out of 2x cubed, there's just 1 x left over in this term. And when you divide 10x squared by 2x squared, 10 divided by 2 is 5. Can we do the same thing for the next group? Pause the video and see if you can figure out what to pull out. This one's a little easier. Hopefully we were able to figure out that we can pull out a plus 3. 3x and 15 can both be divided by 3. So when we put the rest in parentheses, 3x divided by 3 is x, and 15 divided by 3 is 5. Little bit of a flashback to 7.6 here. How do I know I've done this right? I don't just want to guess that I did it right. I want to know that I did it right. You know that you've done one of these problems right if whatever is inside of the parentheses matches. Because, just like we did with the AC method, the matching pair goes out front and becomes one of our binomials, and the leftovers, 2x squared and 3, become our other binomial. This is how we factor by grouping. It's just the second half of the AC method. We know how to do this one already. Let's try a practice problem. Let's flip over, in fact, to page 242. And I want to see if we can practice a factoring by grouping. I want us to try number 4 for a very specific reason. Remember, the rule is you want to make sure you can pull something out of the groups that you make. Pause the video. Take a look at number 4. Do what you can. If you can solve it, fantastic. If not, we will talk about some methods to make this problem a little easier for us. Try it out now. Hopefully you've had a chance to get this started on this one. Let's take a look. So problem number 4 is, oops, it ever zooms in, 5t cubed plus 6t squared plus 5t plus 6. Now, if I wanted to make 2 groups, I would most likely just put a group around my first 2 terms and a group around my second 2 terms. And while this one works for this problem, it won't be very pretty. If I made my groups here, like this, what can I pull out of my first term? Well, 5 and 6 don't divide each other, but the t's do, so we can put out a t squared. And in parentheses, we would just have 5t plus 6. But what will we pull out from this last group? Uh-oh. 5t and 6 don't have a common factor. Well, if you are clever about it, you do know that 5t and 6 do have a common factor. Both can be divided by 1. So you could put a 1 in front, your 5t plus 6 inside, because 5t divided by 1 is 5t, and 6 divided by 1 is 6, and recognize, oh, we did this right, the pairs match up. Our answer is going to be t squared plus 1 times 5t plus 6. But let's say you didn't want to do all that. Let's say you didn't want to have to deal with the fact that you couldn't pull a factor out. Since all 4 of these terms are just being added, you can rearrange your terms. Yeah, if they're being added or subtracted, you can rearrange the order. Just make sure that the subtraction sign carries with the term that it's attached to on the right side. So I want to rearrange my terms such that I can pull more out. In fact, I'm going to rearrange it so that 5t cubed is next to my 5t. And I'm going to rearrange it so that my 6t squared is next to my 6. And now when I make the groups, you'll see that we can pull even more out than we did the first time we did this problem. Here, they'll just have a t in common. They've got 5t in common. This would be 5t on the outside, and we'd be left with t squared, excuse me, t squared plus 1 on the inside. The second term, we can pull out a 6. So we would do plus 6. On the inside, we'd be left with t squared plus 1. Notice the terms match up, and also notice that when we write out our answer, It's the same answer. 5t plus 6 times t squared plus 1. Grouping usually works out this way, but I do recommend if you can't find something to pull out from both groups, rearrange your terms. There is no need for you to try to pull something out that doesn't exist. With that said, there is only one more topic that we are going to be talking about, and it is called factoring completely. Let's take a look back on page 241. Now, when we finish a problem, we want to make absolutely certain that we are done with the problem. There's nothing else we need to do. For instance, let's say I gave you the following problem. Let's say I gave you this. 4x squared plus, let's do 28x plus 48. Now, you might recognize that there is something you can pull out of all your terms. You can pull out a 4. So if we divide all of our terms by 4 and pull the 4 out, we'd be left with 4 times x squared plus 7x plus 12. But we wouldn't just stop and say, oh, look, we're done. Because look what we have here. We have a trinomial. We know that we can factor these. We've factored these many times before. So in addition to pulling our 4 out and putting that in front, we can also factor this middle part as 2 separate binomial factors. So we ask ourselves, using the simple factoring method, what multiplies to make 12? What adds to make 7? The answers are 3 and 4, because 3 times 4 is 12, and 3 plus 4 is 7. So our answer would be 4 times x plus 3 times x plus 4. This is what it means to factor completely. When you finish a problem, ask, am I really finished? Or is there something else I can do here? In fact, on page 241, there's a little bit of a checklist. Now, the checklist is optional. You only need to use it if you're not sure if you're done. But it can be very helpful. To factor a polynomial completely, it recommends factoring out the greatest common factor first. Well, we know that. That's something that we've always done, is we have to say you must factor something out if you can factor something out. Look for a difference of 2 squares, which is a pattern that we recognize. Then, if you've done all of that, you can factor your trinomial using the AC method, box method, or simple factoring, depending. Finally, if you have any 4 terms, you can factor it by grouping. So, let's take a look at the next page, page 240. It's actually 243, I apologize. Page 243 is the page we want to look at. I want us to take a look at problem number 9 and problem number 13. For problem number 9, we ask ourselves, what can we do here? And you might be tempted to say, difference of 2 squares. Well, let's see. We've got a difference here, but 4c, that's just 4 times c, or 2 times 2c. It's not a perfect square. But we remember that if you can factor something out, you must factor something out. And in this case, both of these have a 4, and both of these have at least one c. So let's pull out a 4c from both terms. What's left over after I factor out a 4c? Well, I'd have 2 c's left here, so let's c squared minus 4c divided by 4c is 1. We might say, oh, we are so clever. And you are. If you got this far, you are very clever. But are we done, is the real question. Have we factored this completely? Now you might recognize that c squared is c times c. It's a perfect square. 1 is 1 times 1, so that's a perfect square. This is a difference of squares inside of our solution. It means we haven't factored completely. It means that we also need to factor c squared minus 1. Well, the difference of squares pattern tells us we take the square root of the first term, which is c, We take the square root of the last term, which is 1, we put a plus sign in between one pair and a minus sign in between the other. And again, if you're looking for help with this, go back to 7.7. This is factored completely. This is not. Let's touch our skills again with problem number 13. Remember the steps that we talked about. Try number 13 on your own. Try to see if you can factor completely. Afterwards, we will discuss. So pause the video here and try number 13 for yourself. Let's take a look. So, problem number 13. You might recognize all of these terms have something that can be factored out. 20, 22, and 12 can all be divided by 2. 2 is the greatest common factor. So we factor out our 2, and we write 10p squared plus 11p minus 6. Fantastic. What do we do from here, though? Well, can we factor out this middle part? There's no common factor, but we know that even when there's not a common factor, if we have an a value, this 10 here at the front, we know that we can factor this using the AC or box method. We use the AC method so we can get some more practice with grouping. So we set up our combinator with a times c at the top. Well, 10 times negative 6 is negative 60. And on the bottom we would have 11. So what multiplies to make negative 60 and adds to make positive 11? This is a tough one. The answer is positive 15 and negative 4. So the next step is we want to split our middle term. Mr. Straker, we've got this 2 out here. Doesn't matter. The 2 is here for the ride. It's here to stick around. We are not going to do anything with this 2. It has been factored out. It has done its part. But we do want to focus on what's left in parentheses. So we've got this. From here, you could use the box method if you wanted to. I'm going to use the grouping method just so that we can get a little better practice with it. According to the grouping method, we should group together terms where you can pull something out of. I can group those together. Because, let's think about it. What can I pull out from the first group? You can tell here I'm going to need some more space. From this first group, I can pull out 5 and p. Because 10p squared can be divided by 5p, and 15p can be divided by 5p. So we're good. When writing out your parentheses, keep your 2 separate. So I used a different type of bracket here. I used a bracket instead of parentheses to show how separate it is from everything. And then we continue the problem like normal. 10p squared divided by 5p is 2p. 15p divided by 5p is 3. What can we factor out of the second term? Both are negative, so let's factor out a negative sign, and both can be divided by 2. So we factor out a negative 2. Negative 4p divided by negative 2 is just 2p. Negative 6 divided by negative 2 is positive 3. And how do we know we did this right? Because the groups match. If the groups match, we are good. So our final answer is 2 times our parentheses, 2p plus 3. And what's left over? 5p minus 2. And we're done. As a brief reminder, anytime an equation equals 0 at the end, such as in problem 19, where we would have our solution as c squared times c minus 9 times c plus 9, that will be the solution to problem number 19. If it equals 0, just set each piece equal to 0, each factor. So set c squared equal to 0, figure out what c should be. Set c minus 9 equal to 0, see what c should be. And set c plus 9 equal to 0, and see what c should be. That's how you would find your answers, or your roots. or your solutions, is when it equals 0, set each piece equal to that 0 after you factor. Alright everybody, that concludes Unit 7. Thank you so much, and as always, if you have questions, feel free to reach out and email me. We can schedule a one-on-one, whatever you need. With that said everybody, have a fantastic rest of your day.